So when we started solving our trig functions, we realized that we could have an infinite amount of answers. As we keep rotating around our unit circle, we just get more and more answers. So there is actually a way to show every single answer out there without having to constantly rotate. So let's take a look at what happens with generic solutions. So here we still have to isolate our trig function, so I'm going to divide by 2. So we get sine of theta equals -1/2, and then we take our sine inverse. So theta equals the sine inverse of -1/2. So this is asking where does sine equal -1/2. If we look at our unit circle, sine is going to be negative here and here. So that means theta is going to equal, that is 7 pi over 6 and 11 pi over 6. But as we keep rotating around that unit circle, we're going to be repeating this ratio of -1/2 for sine. So what I'm doing is I'm rotating here, but as I keep rotating, each time I cross these lines, that's another solution. So as we've seen before, when we had to rotate, say, 4 times, or we were rotating backwards, or we needed to find a coterminal angle, we just add 2 pi to our solution. And that's what we're going to do here. So I'm going to take my 7 pi over 6, and I'm going to add 2n pi. The n is going to keep me rotating. So if I plug in 1 for n, I'm adding 1 circle. If I add in 2 for n, I'm adding 2 circles. 3n, 3 circles, so on and so forth. So again, this is saying n is what's making this infinite. So all I'm doing is I'm adding all of those coterminal angles by adding the 2n pi. So I'm going to do the same thing, 11 pi over 6 plus 2n pi. And those are my solutions. Okay, pretty straightforward, nothing too fancy there. I'm actually going to create a third problem just so we can talk about tangent for a little minute. But let's go ahead and solve this cosine. So I'm going to minus the 4. So we get cosine of theta. That 4 is going to become a minus 8 over 2. So we're left with root 3 over 2. So theta equals the cosine inverse of root 3 over 2. And on our unit circle, positive cosine, that's going to happen here and here. So that's at pi over 6 and 11 pi over 6. And we're just going to rotate around that unit circle. So pi over 6 plus 2n pi and 11 pi over 6 plus 2n pi. All of my solutions, infinite solutions there. Now we're not restricted to 0 to 2 pi. These are all of our answers. Okay, tangent is a little bit different just because of its position on the unit circle. So we're going to just take a quick look at this one so we make sure we understand what's going on here. So let's say we have the tangent of theta equals 1. Okay, so theta equals tangent inverse of 1. So theta equals pi over 4 and 3 pi over 4. So if we look at our unit circle, pi over 4 is here and 3 pi over 4 is here. So what we notice is if I add pi, I'm here. If I add pi again, I'm here. So instead of having to add 2 pi every time, I only need to add pi. So my final solution, or my generic solution here, is going to be pi over 4 plus n pi, because I only have to add 180. If you were to still list this as pi over 4 plus 2n pi and 3 pi over 4 plus 2n pi, you're not wrong. It's just a little bit longer, a little bit more work. Okay? So that looks pretty to me. Finding our generic solutions to our trig equations. Go forth and solve.